Okay, what transformation moves the complex number z to the complex number iz? Alright, let's think about what this means. So we're taking z, we're going to multiply it by I, and we need to describe the transformation that takes place when I go from z to iz. Okay? So let's think about what is happening here. We'll talk more in detail about different types of transformations involving I, but let's start with how to approach this. Okay? Well, it's not very clear whether we need to do translations, shifts, okay, stretches, or compressions, because those are the transformations that we've talked about. Let's see if that is really what's happening here. Okay, so if I say, let's say z is, let's just write this in component form, in complex number form. So if I say x plus yi, okay, where x and y are real numbers, then what would happen to iz? Well, iz then is really, remember we said this is just I multiplied to z. So if I multiply this by z, what happens is I have I times x plus yi. Okay? Now what happens here? We distribute the I, okay, so we end up with xi plus yi squared. Okay, and this becomes -1, so we have negative y plus xi. So you can see here that the value of x and y changed, they switched, and the y became negative. Okay? Now let's say that z is equivalent to some point xy. Okay, because that makes sense, since that would be, if that's the complex number form, this would be the point form, the location, I should say, of where z is on the Cartesian plane. Okay, so if this is the case, then iz could be represented by a point p prime, where the coordinates of this p prime, and we're not talking about derivatives here, okay, we're just talking about another point p, would be where the real part is negative y and the imaginary part is x. So we have minus y and x. Okay, so if you try to observe what's happening, that doesn't really tell us a whole lot unless you are familiar and remember from geometry how this and this are related. Okay, let's see. Before we do that, let's do one more observation here. You also notice that z, the modulus of z, the magnitude of z, is really going to be the x squared, just x squared plus y squared. Okay, and the modulus of iz is going to be minus y squared plus x squared, which actually turns out to be the same thing. That's just positive y squared, that says x squared, so the modulus, the moduli of these two numbers are the same. So the length of the vector does not change, but the position changes. Okay? How does it change? Let's see if we can graph it. Okay, so if I have, let's say x was 3 and 2, or sorry, let's say point P was xy, and let's just say that x is 3, okay, just for the purposes of this demonstration, 3, and this was 2, okay? Well, then P prime would be minus 2, okay, and then it would be up 3, okay? So that would be P prime minus y and x. And if we draw a vector here, you'll notice, and you know, I mean, this has to be drawn to scale somewhat to really observe what's happening. We have these two vectors, and you will see that this is very close to a right angle. Okay, and that is really what's happening. Okay, OP prime. Remember, this is O. Okay, OP prime is equal to OP. Okay, this distance is equal to this distance. So the only transformation that occurs from this vector to this vector is a 90-degree rotation in the counterclockwise direction. So really the transformation is that when I multiply a complex number by I, I'm rotating the vector z, okay? Rotating z by 90 degrees in the counterclockwise direction. Okay? Counterclockwise direction. Okay, so and that actually is a rule. If I multiply any number by I, you will see that it rotates it counterclockwise 90 degrees. And that occurs for every time I multiply a number by I. Okay, and that kind of leads into what I want to talk about here. How does I transform a complex number? Okay, let's start with 1. If I have 1 and I multiply 1, 1 is a real number, but it could technically still be a complex number, right? This is still technically z. It's just the imaginary part is 0. Okay, so I'm simplifying the situation, the problem here. If I have z and I multiply it by I get I. Where is I? Okay, normally I would have this would be my starting vector. That would be my vector 1, 1, 0, right? That's really 1, 0, okay? Because that's really 1, 0, 1 plus 0 I. Okay, so that complex number would be represented by this vector. If I multiply this by I, okay, if I multiply this by I, that's what's happening down here. I end up with 0, 1. The coordinates of this would be 0 and 1, right? So that actually becomes 0, 1. So we end up with this vector. Oops, let me just straighten that line here. We end up with this vector. So you can see here that I've rotated, when I multiply by I, I'm rotating 90 degrees counterclockwise. Okay? And what happens if I multiply I by I? Okay, then I have I squared, 1I squared, that's equal to negative 1, and so you see that that ends up with this vector minus 1, 0. Okay, so every time I multiply by I, you will see that it rotates whatever number, okay, any complex number, it will rotate at 90 degrees in the counterclockwise direction. Okay, it does not change the it doesn't really change the length unless I multiply, unless I multiply this by another complex number with a real part and an imaginary part. But since I'm just multiplying by an imaginary part of 1, this is what is happening. Okay, so very interesting how I affects a complex number. Okay, so this might be useful for some questions that are in the textbook. All right.